This is a quick video. Now we've done a bit about radioactive decay, activity, and half-life to show you how to work out the half-life of an isotope, a radioactive isotope from a graph, and also how we can work out the fraction of remaining radioactive atoms after a certain amount of time has passed. So, moving on, this is the kind of graph we'd expect to see. On the y-axis, you can see that we have a count rate of sorts, counts per 30 seconds. On the x-axis, we have time. As you can see, as time goes on, the count rate is decreasing. What I'm going to do, first of all, in order to work out the half-life of this isotope, is I'm going to add some lines. These lines, I can choose wherever I like on the y-axis to begin with. I'm going to say a count rate of 140. One half-life, I'd expect that count rate to half. So I'm going to draw a line, a horizontal line at 70 as well. So I've marked two lines in indicating the activity is halved. Now I want to know how long that took. So as I'm sure some of you have already sussed, we're going to draw two lines down and we're going to read off the x-axis and see what the times are at 140 and 70 counts per 30 seconds. So 70 seconds and 225 seconds. So how long did that take for the count rate to half? 225 minus 70 is 155 seconds. Therefore, the number of count rates halved in 155 seconds, the number of radioactive atoms must also have halved. If you don't believe that this is going to be the same everywhere on the graph, I have done another quick one. So the half-life to 155 seconds. This time I have changed it. So we're looking at halving from a count rate of 80. And again, we can see that it comes out with the same answer of 155 seconds for the half-life. So no matter how many atoms there are, this radioactive isotope is always going to have a half-life of 155 seconds. Good. So part one done. That's how we work out the half-life of an isotope from a graph. The second thing we need to do is, if we know the half-life and we're given a number of radioactive atoms, how can we work out the number of radioactive atoms that are left after, say, a minute, 2 minutes, or longer, an hour, if we know some of them have decayed? So in this case, I've got 6 times 10 to the 8 radioactive atoms at 30 seconds. How many are there going to be after 495 seconds? Okay, first thing to do, the time that elapsed between 30 and 495 seconds is going to be 465 seconds. How many half-lives are there in 465 seconds? 465 divided by the half-life, which we know is 155, is 3. So 3 half-lives have passed. If 3 half-lives have passed, we'd expect there to have been 6 times 10 to the 8 radioactive atoms. That's going to half once, half twice, half 3 times. So the fraction remaining is going to be a half of a half of a half of 6 times 10 to the 8 radioactive atoms. In other words, we can do, or in other numbers, half times a half times a half, or a half cubed is going to be 1/8 of those original atoms are going to remain. We simply do 1/8 of 6 times 10 to the 8, and we get 7.5 times 10 to the 7 radioactive atoms are remaining after those 465 seconds have passed. If we wanted to work out how many had decayed, we'd do the original number, 6 times 10 to the 8 radioactive atoms, and then we'd subtract the number that of radioactive atoms that are left. So 6 times 10 to the 8 minus 7.5 times 10 to the 7. But 7.5 times 10 to the 7 is the number of radioactive atoms that are left. Good. So that video has recapped for us how we work out the half-life of an isotope from a graph and how we can work out the fraction of remaining radioactive atoms and also the number of remaining radioactive atoms.